Well, ladies and gentlemen, it's a real honor to be here, and this is going to be something of a change both of theme and pace in terms of what we're going to talk about. And we're here to talk about water, and as most of you know, water underpins everything that we do, all the food we eat, everything that we actually have, and yet we take it for granted. And really what we're going to talk about is India and water, but here and there we'll go back to the globe and see what we actually know and why it's important economically. Let's start by looking at, excellent. Let's start by looking at the global picture. In this map, what we actually have is something pretty simple. We take the supply of water, which is pretty much fixed right across the world, and on top of that, we put population growth rates. So it's a very, very simple overlay. And what you see that there is scarcity, places in red that are emerging, and they emerge right through South Asia, and they emerge right through Africa, and in many of the places in Africa where you see red, I'm not asserting causality, but you also see fragility and you see a lot of conflict actually occurring over there. So we're going into a world with increasing water scarcity. What if we do the same exercise and zoom in, going the wrong way. We zoom in a little bit more into India, and we compare India to China for very, very obvious reasons. We see that there's a much, much steeper decline, much more scarcity of water that we face in India going forward and into the future than we do in China. And of course, much of this is just simply driven by population and population growth that we have, and the fact that all else equal, the supply of water is fixed. And you know what? Demand going up, supply being where it is, guess what's going to happen? Much of India will face water scarcity. The other aspect that we have about India, which is unusual, and South Asia, is the monsoon. A feature of the monsoon, of course, is that you have a lot of interannual variability. What this map tells you is that in any given year, you'll find a district somewhere or the other in India, more than one district typically, that has a massive dry shock. And by dry shock, I mean one standard deviation away from the mean. So that's, say, out of 100 years, about the 10 to 15 driest years that you would have. So there's always somewhere or the other in India, no matter what the annual average rainfall may be, that's suffering from a dry shock. You could do the same thing for a wet shock. I'm not going to talk about that for reasons that will become obvious. But, of course, as a consequence of all of this, the dryness that we have, the lack of water that we have, India has invested very, very heavily in its irrigation infrastructure. India is the largest user of groundwater in the world, and India is the second largest builder of surface irrigation dams in the world. And there's an order of magnitude difference between the amount of water that India uses and the amount of water anywhere else in the world actually uses. And I would say that's in many ways a good thing, because it has achieved pretty good things. In 1950, or you could go back to independence, 1948, India was in a profound food deficit and remained there all the way up to about 1960. Now there's massive food surpluses in India. And indeed, India is the 9th largest exporter of water in the world. There is enough food around. If anyone is hungry in India, it's not because there's not food. It's purely a distributional issue. And we also know, again, I think there's probably causality, though I'm not going to assert it, that when we get increased rural productivity, we do see declines in rural poverty as well. So it has been overall a success story. There's always a but and there's always a however, because we're talking about natural resources. Let me skip that slide. The but and the however is a lot of this has been achieved by depleting the supplies of groundwater that we actually have. So this is the global map that you'll see. And if you look at India and you look at that spike, the spike tells you how deep your bores are, the level of stress of your groundwater. It's much, much deeper than anywhere else that you see in the world. Let's now zoom into India. I'll show you 3 maps. One of them was supposed to be animated, but this is a PDF, so you won't see this animation. This was supposed to take you from 1996 to 2014, and the colors just go, sort of darker and darker where the groundwater depletion occurs. These are all, by the way, official numbers. But maybe it's the map on the right, which is quite a good one, because it's looking at demand versus supply, where year on year you're drawing more water than is being replenished on average, and we see where that's happening. And where that's happening, of course, is in dry zones and in zones where we have more water-intensive agriculture. So given that water resources are under stress, one very simple question to ask ourselves is how productive is that water? We can become more sophisticated, calculate TFP and everything else, and a very simple statistic will tell us that China gets more crop or dollar per drop of water, agricultural water, 4 times more than does India. So crop per drop, if you like, or dollar crop per drop, is 4 times more productive in China than in India. That tells one, all else equal, that one can actually improve productivity. Then if we go back to, I want to go back to, if I can. No, it's not coming. No, okay, it doesn't matter. Yeah, I want to go back to this slide, sorry. It was in the wrong place. And of course, what you're seeing over there, if this is the growth rate of agriculture over time, it's been a pretty constant, somewhere of the order of 3%, with a lot of volatility over there. So you've not seen any major spikes that you would actually want to see. So we've had heavy investment in irrigation, and on average it's worked. And wherever you have that investment, on average, you see productivity actually improving. But the other role of investment is to provide you with a buffer against rainfall shocks. So let's ask ourselves the question is, if we get a rainfall shock in a district of 1 standard deviation, what happens when you have irrigation and what happens when you don't have irrigation? So before we answer that question, let's ask ourselves, on average, across India, I get a 1 standard deviation shock. What's the average treatment effect? What is the average impact on productivity? And you get a decline in productivity of 7 to 11%. When you get a positive shock, more rainfall, as we know, almost everywhere in developing countries, more rainfall, even if you worry about floods, is actually good for agriculture. And I can answer that and explain that to you just in the process of writing a paper on that, why that's actually occurring, but we won't talk about that right now. Where you have groundwater, this is the other thing. Where you're growing water-intensive crops, things like rice, cotton, and sugarcane, and you get a dry shock, of course, the decline is much greater. It's more than twice as much as if you weren't growing those crops, all else equal when you standardize the regression. So now let's ask ourselves this, if you like, this really important question. Massive investment in surface water irrigation. How well does the surface water irrigation buffer you when you get a 1 standard deviation or more shock? And here we follow a whole bunch of papers, some published in very good journals like the American Economic Review, and just replicate what they've done with actually global data and then zoom into India. And this is what we actually find. Is when you build surface water irrigation, what you find is that farmers switch from whatever they're growing to more water-intensive crops. So they start growing things like rice, sugarcane, and cotton in arid and semi-arid areas where we gave them new irrigation water. And of course, the reason why they're doing that is we're providing them the water, perhaps justifiably for free, so we're providing an economic signal that says water is abundant, when in fact water is physically and ecologically scarce. So if water is economically abundant, you treat it as that, and you start growing these water-intensive crops. Then comes the drought, then comes the dry shock, and the dry shock always comes, as we've seen, there's not enough water. So you get a collapse, and revenues decline by so much that on average it's going to take about half a decade to a decade to recover from that fall in the revenues that you've had. And the reason is quite simple, you've run out of water. If you're a scientist rather than an economist, you'd call that maladaptation. If you're an economist, you might think about it as moral hazard or give it some other label that you actually wanted to. So this is what you see with surface water. When you have groundwater, when you have conjunctive use, there's much less of a decline. But of course, you get exactly what you'd expect with the declining, depleting groundwater. That buffering impact is actually declining over time. What you also see, and I didn't put those statistics up, is that productivity, agricultural productivity, where you have groundwater and it's not overly depleted, is on average higher than if you did not have that conjunctive use or sole use of groundwater. The reason is very simple. If I have a bore that's working, then I can irrigate when I want, how much I want, wherever I actually want. If I'm relying on surface water irrigation, it depends on someone else determining when the water actually becomes available. So let me skip that. So we've spoken about the quantity of water. The other thing to talk about is the quality of water. And quite often when we think about the quality of water, we think about sanitation. We know that's very, very well handled now and increasingly well handled now in India. I want to talk about another problem. And this is a global problem, that of nitrogen pollution in water. And we'll go into how much of a problem it is or it isn't in India. The thing to note about most nitrogen in water that you see mostly anywhere in the world is it's due to nitrogen fertilizer. And as you look at this map, you will actually see that nitrogen fertilizer usage has increased dramatically in India. And that is, of course, part of the Green Revolution. And it has enabled a huge increase in agricultural output that clearly would not have been feasible without this use of nitrogen. But what we know about nitrogen, at least globally, the global statistic is that if I put some nitrogen down on the ground, only 40% of that nitrogen is actually absorbed by the crop and remains in the soil. What happens to the remaining 60%? Some proportion of that 60% will be leached into water, and it's toxic at high enough concentrations. Some other proportion of that 60% will be vaporized into the air and form nitrous oxide. And nitrous oxide is 300 times more potent in its heating potential than is CO2. But we also need to worry about the fact that these are all of these externalities, even though we've got the productivity increase, and it's not just India, it's global, which is why the scientists who've talked about things like planetary boundaries will tell you that one of the planetary boundaries that we have crossed, and you can see at the bottom there, is a nitrogen planetary boundary. And Bonnie Keeler, who's at the University of Minnesota, she's spent her life working on nitrogen, argues that nitrogen is the world's largest externality, greater than even carbon, she argues. You may or may not want to believe that. And of course, it's trending upwards everywhere, including India, as we saw. So why are we particularly worried about this? One is, of course, the fact that we've crossed the safe planetary boundary, but there's a health impact of nitrogen that we're going to come into. There's a health impact, and there's the fact that you have too much nitrogen in the soil. A lot of it is going to end up in groundwater. Wow. And these are official numbers, and wherever you see red, you've crossed the safe threshold of groundwater that's set by the government of India. So it's all over the place. What does this increase in nitrogen actually do? One thing that it does, and the reason why everywhere in the world we are so strict about nitrogen, is it causes blue baby syndrome. Blue baby syndrome means the blood doesn't flow well enough amongst babies, they turn blue, and it can be fatal. But of course, it's not fatal to every single baby. So the question that we can then ask, and of course we know we have very good data on this, is what happens to the babies in the world, including in India, that survive excessive dosage of nitrogen? And we can use the data on stunting, which is a reasonably good marker of development that we actually have. And what we find is that babies, and of course the data, as many of you will know, is based on girls, babies that are exposed for the first 3 years of their life to high enough doses of nitrogen end up being stunted. Whatever you might think of the stunting statistics in India, it's 2 centimeters, which is basically losing 50% of the average height gain of women, which was 4 centimeters roughly since about independence. You see the same sort of thing happening where we have data in Vietnam, Africa, and elsewhere as well. Okay, so I'm going to end over here. So what I've pointed to is the great benefits that we actually get from water, the necessity of water. And one of the things you would have noticed about water is that the use is sequential. All the water that you see around you and that you're consuming has always been here, that molecule of water. You can make it unusable and dirty, but it's always been around. And because the use is sequential, that actually means that what I do to the water is going to affect someone else. And what we want from economic policy is what I call here the economic water cycle, is to look at water from its source in the mountains to the sea where it goes. And the mountains where we actually have water, that's our watersheds. Water is a public good. They'll need to have the infrastructure, transform it into a private good. But if I don't worry about the pollution, whether it's from my farm or whether it is from my factory, it's going to go back into the system and hurt someone or something else. So therefore, we need to worry and have the appropriate regulations for that as well. And that, the other speakers that we have over here will be talking more about later on. But that's it from me. Thank you so much. Please.
I'm Leila Fernandez. I'm an academic. I've been a tenured professor in the United States for 27 years. And I publish widely on questions of economic change and inequality in India. And my most recent book is on governance of water in India, which is what I'm going to talk a little bit about today.
I'm Vikram Singh. I'm one of these things is not like the other, because I'm the former Deputy Assistant Secretary of Defense for South and Southeast Asia. I focus primarily on technology and security issues, but Amit was brave enough to let me venture into water and security issues, where I currently am at the United States Institute of Peace, and we do a fair amount of work on water and climate security. So I'm going to talk a little bit about India's security-related concerns related to water.
Satyajit Singh, I teach at UCSB. I used to work in Delhi University for a long time. I have been working on water for some time now.
Siddharth Desai, I work in the capacity of Joint Managing Director at Kishore Pumps based out of Pune, India. We manufacture pumps and allied equipment for wastewater treatment plants. I also serve on the India Water Leaders Council with C Ganga. It is the policy and technology arm of the National Mission for Clean Ganga program by Ministry of Jal Shakti. And I also serve on the advisory board of Indian Biogas Association, which is kind of linked to the water economy as well. Thank you.
Leila, why don't we start with you?
I think if the PowerPoint could come on. Yeah, thank you. So I'm going to talk a little bit about water governance today. And sort of building on what Richard just talked about, agriculture is still one of the biggest users of water, but their drinking water needs, and with all of the policies we've been talking about all day, their expanding needs of industry and also urbanization is also leading to expanding demands on water. In addition to that, climate change is going to complicate governance over water. For example, the possibility of intensive cycles of floods and droughts make water governance very difficult at the local level, as local chief engineers and sort of local engineers have to kind of manage reservoirs and sort of figure out the levels of water reservoirs in order to have enough water if there's drought. But then if you keep too much water in the reservoir, you have the threat of floods if you have an extreme monsoon. So there are going to be incredible challenges to water governance, which are going to affect all of the different policies which we talked about all of today. What I'm going to do in my talk today is I'm going to talk a little bit about reforms in water governance. And I'm going to focus on the things which we've been building on towards during the course of this conference, which is to think about the importance of state bureaucracies, particularly of local state governments, in managing sort of the governance over water. And also to think a little bit about how the institutional reforms which have been implemented regarding the management of water are actually taking place on the ground. So a lot of what I'm going to talk about is going to be based on sort of ground level fieldwork. And the two principles, of course, are decentralization and privatization. But for the purposes of this talk, to keep the talk concise, I'm going to focus mainly on decentralization. So I'd like to foreground two things before I get into a summary of some of my findings. The first is I want to talk a little bit about how authority is re-centralized within states in India, at the local level of the state government. And I want to foreground that because I want to think through and move away from a spatial understanding of decentralization, where we tend to think of decentralization as pushing power down, as we talked about today, some of the regulations which have gone away, and to think about how, when you push authority down, authority can actually get re-centralized in complicated ways at the level of states and state governments. And this has implications for water governance, as we'll see in a minute. And second, I want to talk a little bit about how institutions can reproduce inequality in this process of re-centralization, and how important it is for us to understand how institutions work at the local level if we're going to talk about some of the challenges of inequality which we're dealing with in India today. So I'm going to focus on the state of Tamil Nadu. There are a number of reasons why I'm focusing on Tamil Nadu. It's been one of the states which has been at the forefront of implementing global and national reforms, focused on decentralization and privatization. It was one of the first 3 states to implement the World Bank's World Resources Consolidation projects. And it also has a really good model of drawing on finance capital for infrastructure development. So let me just say a little bit about the research I did, which I'll be summarizing the findings. We talked a little bit about data today. The data that I use as political scientist is very different. I actually use original data, which I gather myself. And in this case, what I've done is actually I spent many years doing an intensive study of the water bureaucracy in Tamil Nadu, where I basically analyzed original policy, mainly unpublished policy documents, government documents, as well as conducted interviews with the key elements of the water bureaucracy, the Public Works Department, the Water Resources Organization, and Metro Water, main utility. If any of you are from Chennai, you would recognize the name. And so part of what I've done through this research is I've really been interested in understanding how local state government organizations and bureaucratic organizations actually work on the ground, because they are really the ones who implement the sort of reforms which we talk about at a macro level. And although there's been a lot of focus amongst academics on the need to think about states and state governments, there's actually very little academic research which looks at how bureaucracies work. There's a lot of work which talks about corruption. There's a lot of work which talks about the need to decentralize. But there are actually fewer case studies which go and sort of look at what is actually happening with bureaucrats. What are they actually doing on the ground? So I spend a lot of time talking to bureaucrats, spend a lot of time in the Public Works Department looking through the archives. And when I say archives, basically these are rooms where the clerk had to basically break off the locks because no one had ever wanted to look at the documents before. And what I found was actually a treasure trove. They had everything from original colonial documents from the British government, which were actually almost like breaking off as I was turning the pages, to every single World Bank document, to all of the government memos. So I got a real sense of the texture of the bureaucracy and some of the challenges which are being dealt with. So what I'll do is I'm going to just, because we are supposed to speak for 8 minutes, I'm going to just summarize the main findings. The first is that I found that when we think about decentralization being implemented on the ground, what actually happens is not necessarily a devolution down, but what we could think of as a redistribution of institutional authority between different wings of the bureaucracy. And a side effect of that is that the water bureaucracy tends to be treated as a closed system. So what this means in practice is that decisions about how you manage water are separated from, for example, land usage or urban development. But then when you have the challenges that you have in terms of competing demands over water, those are actually institutionally segregated out, and water governance becomes crisis management because it's not really part of the urban development planning. Secondly, institutional authority actually just simply moves around. So as we'll see in a second, in the contemporary period, it tends to move away from the rural bureaucracy to the sort of metropolitan city authority, which has also consequences for how we think about inequality. The second point I'd like to summarize is that the water reforms tend to produce and reproduce inequality between metropolitan cities on the one hand and smaller towns and peri-urban areas. So we have a need to sort of think about the urban in a more complicated way. And secondly, what this does as a side effect is it allows for what I would call an extractive state that transfers water resources based on socioeconomic inequalities and urban-rural inequalities. And I use the word extractive to oppose it to sustainable. So what happens is the state, in a sense, gets into a mode of crisis management where it then has to extract resources in order to deal with sort of a crisis of water scarcity, which Richard was laying out for us. And then finally, a decentralization itself tends to be shaped by the institutional and financial weakness of small towns and rural areas. So for example, urban local bodies are too financially weak to qualify for private finances, so they tend to be more dependent on the state government. The more well-off urban ULBs tend to be able to draw on private financing, but what that does in turn is it weakens the rural bureaucracy, which then makes it much more difficult for rural bureaucrats to manage agricultural water supply and demand. And then finally, institutions such as water user associations have tended to become enmeshed in the top-down state bureaucracy, so that on paper, it looks like there's decentralization because you have WUAs set up, but in practice, those WUAs are simply integrated within a vertical bureaucratic structure of the state government. So those are basically a summary of the findings which my research has shown. And what I'll do is I'll give you just one example to give you a sense of what I mean by that. So the example which I'm going to talk about is going to be, in a sense, the flip side of your discussion of groundwater. And I'm going to talk a little bit brief, and I'll try to be brief, about regulatory reform and groundwater extraction in the city of Chennai. So in response to the overuse and the over-extraction of groundwater resources, which were depleting groundwater reserves, similar to the map which you presented, a series of reforms were set into motion by within Tamil Nadu, and they were modeled on the national bill. But what the state did was it basically carved out two separate sets of regulations, one for the city of Chennai and one for the rest of the state of Tamil Nadu. And in that legislation, it empowered the metropolitan city utility, Metro Water, to have power over sort of water usage. So the separation of the legislation meant that the regulation actually worked in Chennai. So it actually had a very positive effect in the city of Chennai, and actually the depletion was reversed in the city of Chennai. But what it did was it allowed the utility Metro Water to basically extract groundwater from the rest of the state because those regulations were separate, right? So in a sense, it bifurcated the legislation, and that in a sense empowered Metro Water, the utility, to engage in basically unregulated pumping from the rest of the state. And so technically it was doing really well with the regulatory reform within the city of Chennai, but it had license to basically engage in the over-extraction of groundwater in the rest of the state. And a lot of this involves negotiating with farmers, sometimes pressuring farmers to pump groundwater and sell it through groundwater markets. So what this does then in terms of inequality is that processes of re-centralization become intertwined with various socioeconomic inequalities, such as rural-urban divides, inequalities within rural areas. For example, there's a lot of conflict on competition in terms of who benefits from groundwater markets. Farmers who have the capital can buy pumps quicker than those who need government loans. And so they may deplete the water of their neighbor's farm, for example. And so there's inequalities in those markets. And it also then dovetails with power dynamics of social inequalities, which we were talking about in the last panel. So for example, the top-down nature of WUAs mean that gender dynamics get reproduced because women who should be participating in the WUAs tend to be marginalized by existing state structures. So in conclusion, then, part of what I'm trying to do through my presentation is to talk a little bit about how critical it is for us to understand how local bureaucracies work in order to think about the effectiveness of institutional reforms. Secondly, it's critical for us to open up the ways in which the governance of water has been treated as a closed system and to begin to integrate it much more consciously in the ways in which we think about industrialization, urban policy, investment planning, because as these cycles of drought and floods become more intense, we're going to start to have these kinds of moments of crisis break out. So for example, just if you look at southern India, the extreme droughts in southern India impacted the IT sector, right? So the sectors which we might think of as sort of segregated will actually be impacted by these sort of broader processes of water governance. So I think I'll just stop there.
Great, thank you so much.
Sure.
Brilliant.
Well,
Okay, thanks, Richard. So I'm taking a sort of different tack on water for India, but water security is one of the most critical challenges for India in the 21st century. I think it's widely recognized by the government. I divided up into sort of three rings. The first is what we've been talking about here, sort of water for the population domestically, whether that be for agriculture, for industry, or for individuals. And you've seen significant steps by the government to try to extend the reach of tap water, the Jal Jeevan mission, to households, to try to make sure that water's available for the high-tech industry and manufacturing sectors that the government wants to incentivize to come into India and make investments, and then to try to to try to build on the efficiency to get at this China being 4 times more productive per drop of water vis-a-vis India. So finding ways to be more efficient in the use of water are all government priorities that you see in place. And it's focused really on human security, but it's also an issue of national security for India, because extreme drought and extreme flooding and the inability to adapt in the next probably 20 years to having a much more robust and resilient system for water across all of these sectors could truly derail the sort of economic path that India is setting for itself, and derail the security of the population. Now, more in my wheelhouse as a geopolitical analyst and a security professional are the challenges India faces at the next ring, which is really transboundary water issues. So the 2 big areas that you can look at here are, of course, India-China and India-Pakistan. India-China, Bangladesh and Bhutan share the Brahmaputra. There is no real water management system between the 4 countries. China has a lot of the basin of the Brahmaputra, and there's often popular popular in the media, and talking heads will say, oh, there's going to be a water war between India and China potentially. China's damming upstream more and more. There's a lot of dam projects across the Brahmaputra by both India and China, and it's definitely a source of competition. It's a sort of geopolitical competition. China calls Arunachal Pradesh South Tibet to this day, and so there's a territorial dispute that we think about along the line of control and up to Ladakh, where we saw fatalities and clashes a few years ago. But really, at issue is that an entire Indian state is claimed by China, and the primary area of competition in terms of signaling control of territory is in part the infrastructure along the Brahmaputra River. That competition is more important in many ways than the actual water competition. Varying estimates, but the Chinese probably have about 30% by some Chinese estimates, and as low as 7% of the water in the Brahmaputra is actually from collection that's falling inside China. So China's ability to impact the overall flow is not as big as people might expect, and probably not sufficient to lead to an actual conflict between India and China simply over the water. Over the territorial issues, it's different, and the water management, of course, bears heavily on how those issues will play out in the future. With Pakistan, it's more interesting. It's both a more stable system and potentially a more fraught system. The water issues between India and Pakistan are governed by the Indus Water Treaty. People here will probably know about it. It's one of the more successful treaties in history. 6 odd decades on, World Bank, Pakistan, and India are the 3 parties to the treaty, and it has successfully governed the sharing of water resources between India and Pakistan, despite all the other conflicts that have come out. Pakistan has used turned to dispute resolution mechanisms to essentially object to Indian damming and other infrastructure plans 3 times in the past. But interestingly, this year, India has asked to reopen negotiation and make some fundamental adjustments to the treaty. Pakistan's rejecting that claim for the time being. We'll see. India gave 90 days to say we want to reopen this, and in part this is because Pakistan generally complains about whatever infrastructure projects India chooses to engage in. In its three times of seeking arbitration or dispute resolution, Pakistan lost the first time, got sort of a split decision the second time, and now there's a third where essentially the World Bank has gone for both an independent expert and an arbitration process, which is a little bit confusing to everybody involved and has been a very drawn out process. And what India is saying is we need better dispute resolution mechanisms, essentially, that these aren't working. Of course, India controls the high waters. Pakistan is the downstream state, so you could see where this could be more risky in terms of conflict or disputes over it, or either party abrogating the treaty could, for example, undermine things like the current ceasefire that has preserved for a good long time now on the line of control. So, for Pakistan, Pakistani leaders have often said that this is if India were to do certain things vis-a-vis the waters of uncovered by the Indus Water Treaty, that it would be an act that is seeking to destroy the state of Pakistan. So the rhetoric can get quite heated quite quickly in this area. But the overall lesson of the Indus Water Treaty is that even in difficult circumstances and where there's fundamental disputes between neighbors, and there's sort of an enemy there, really treat each other as enemies, it is possible to manage these sorts of tensions. And ideally, when you look to the east, you would see China, India, Bangladesh, Bhutan developing a mechanism for transboundary water management that is either a treaty or some other kind of an agreement. The third area where India's security really comes into play is just simply climate change, and I'm not going to go into depth on climate change. I have very little expertise in that realm, but whether it's just glacier melt, the irregularity and changes that we're seeing in terms of cycles, monsoon cycles, drought, et cetera. India and its neighbors are in for a very complicated 21st century. And as the impacts of climate change grow, the risks for population displacement, the risks for failures in the food system, food security, it might not be for India, it might just be for its neighbors, but it'll have a spillover effect into India. Those are all sources of potentially great insecurity. And so I will stop there because I'm trying to keep it brief.
Thank you so much. Satyajit.
Thank you. So while we wait for this, I'm going to report on a very low-level value chain conversation which takes place between India and the US. And this is a low-level value chain conversation between UCSB students and the poor in India. And this is about water and climate and how climate is actually affecting the poor in India. But before that, let me also raise a few issues about water and governance. And that is largely that, yes, we've spent about 10% of our total planned expenditure on water. But if you look at the graph in water consumption, then we really are short by 20% in spite of what Richard is saying, that we are still using a large amount of water. Where that 20% is going to come in terms of the gaps, we really don't know. The second question is, if you're spending 10% of your total expenditure, which is public irrigation, then the question is, why is public irrigation? Why is hydraulic rights linked to property rights in land when property rights are so skewed? So those are other issues in terms of distribution and the use of public resources. There is a narrative also on reforms, and Leela mentioned problems of decentralization, but then she's talking about Tamil Nadu. There are success stories of decentralization, and we'll talk a little bit about that. And when you start looking at reforms, then there is a wonderful report by Mihir Shah, which is in terms of restructuring the water bureaucracy. And this is high time somebody took notice about it, because since the 1980s, Robert Chambers was talking about irrigation in the night. Robert Wade was talking about corruption in the irrigation bureaucracy, and we haven't done anything about it. So clearly the inefficiencies which are there and why people are dependent on groundwater is largely because surface irrigation is so uncertain. And that has huge implications. About 90% of your groundwater is being pumped out for agriculture, and as a result, you have serious problems in terms of drinking water quality, which is something about which I work on. So let's look at this conversation which takes place during the COVID times in terms of, and the university structure gives you, how do I move this? This one?
The arrow, down arrow.
That one. Okay, the university structure gives you enough opportunities to work on madness, and one of the things which we did was madness, which is virtual ethnography, right? Which is actually an oxymoron for participatory research. But because the students were kind of caught up in this particular situation, we said, why not? Let's team them up with field-level groups in India, and let's try to understand issues about water and climate and how it is affecting. Largely because the climate discourse in India has been about carbon and not about water, and clearly we were trying to figure out how is it really affecting the marginal people around. And what we did was looked at different agroclimatic zones, we looked at different uses of water, and we worked with groups. So really the dialogue between the UCSP students and the poor was negotiated through many of these field-level groups which were there. So what was our inspiration? Robert Chambers, can we know better? Can we do better? It is about not doing surveys because surveys kind of revalidate existing forms of knowledge. Let's go to the field and find out, oh, what is new there? So really not so much in terms of we know it and this is what we're going to test, but let's look at the aha moments which are out there in the field and the reality which is there. We also took up a perspective where we said, hang on, we are not going to be the producers of knowledge. We are not going to be extracting material, but we will work in partnership with local groups and let them frame the questions of discussion. Of course, our biases were there. Some of the students wanted to work on gender issues. Some wanted to work on issues like groundwater recharge. Some wanted to work on issues of pollution. And as a result, one was able to steer. But really, the overall perspective was not so much in terms of knowledge generation, but in terms of that acting as a catalyst for a process of change and in terms of a policy engagement. So what is it? How is it affecting change? And let's try to understand it. When you look at climate and the data, you usually come up with this figure of 1.5 to 2. Now that is a wrong number. What you really, the right number is really within the range of 3 to 7, because that is a global average. But at different times and different seasons and different locations, the temperature variation can be within that range. And that poses some kind of a difficult situations. So let's look at the Green Revolution, and let's look at Gujarat. That was the first case study. Shorter rainfall days, higher rainfall, and as a result, what you have is the existing problems of Green Revolution, which is there, which was in white, that gets exaggerated by the kinds of issues in terms of climate change, which basically means if you're investing a lot of money in this kind of a commercial crop and you have a crop failure and you really don't have much of a groundwater to kind of depend on, you really have issues, which is. And again, this is something which is happening. People are changing cropping patterns. Richard talked about Punjab, which is now growing rice. Maharashtra has the largest number of dams, about 649, and 40% of Maharashtra is drought prone. So really, when you start looking at the irrigation bureaucracy, the kinds of issues which they are dealing with are really not there. Maharashtra is also the greatest producer of sugar. Let's look at another state, Odisha. Coastal state, and we are looking at a district called Chandbali, which is here. Cyclones, disasters. Groundwater pumping, which leads to greater salinity. Greater salinity means migration. People are moving out from this particular area because your livelihoods are not being able to be protected. That also shows many kinds of opportunities. Salinity also means aquaculture instead of agriculture, right? It's possible to have all of that. But your city water or the village water schemes, the piped water supply systems which you're trying to build with this huge program, and I actually should say compliment the government for actually spending so much money in sanitation and water, because it's huge at a time when you're talking about the state withdrawing away. This kind of an, what was it, about 100,000 1 lakh crores for sanitation. The bank funded a substantial part of it. And you're looking at about perhaps over the last 3 years, you've spent about 200,000 crores on pipe water supply system. The question really is that when you have a system of vulnerability where your groundwater is not being recharged before being pumped out, then you have a problem in terms of sustainability of these systems, much like the sanitation systems, right? If I take you to another village, Naupara, you have this whole problem of decreasing rainfall leads to decreased surface water, increased reliance on groundwater, fluoride, and the kinds of vulnerabilities that kind of gives you. So you really have a situation where climate is already making an impact in people's lives, and this is the process of, we try to map out the vulnerability in different ways which is taking place. Let's go to another village. This is in Madhya Pradesh. Migration, women in agriculture. You have the monsoon, which is being shifted to a 2 or 3 month cycle from a 3 or 4 month cycle, which basically means you really don't the kinds of cropping pattern you move to, like gram, which actually does not need irrigation, or millets and jowar. Those are the kinds of crops you're moving to from wheat, which was your old crop. When we looked at this kind of a process of change, we also need to try, one of the things which came out was in terms of our diet, our culture, our values. So the kinds of festivals which people were celebrating, along with certain crops which they were growing, suddenly they had to buy those crops from the market, right? Because those crops were really not there because of the kinds of seasonality which kinds of comes in. So I can go on and on in terms of how climate change is affecting people. This is the Saharia tribe. Lack of deforestation, your springs getting dried up, lack of rainfall. Again, the Swachh Bharat mission, which has done tremendous work throughout the country. The data which we got was about 80% of the people were defecating in open. The National Health Survey, which has come up with data recently, talks about 70% coverage rather than 100% coverage, which the government would like us to believe in. It also says that people in Madhya Pradesh, Bihar, Rajasthan, and one more state, about 50% of the people are actually defecating in the open. So there is this issue of sustainability, and that is where I would like to talk about an investment in what you would consider social capital, and that social capital leading around the issues of local governance, which can augment capacity. So one bright spot here in terms of how that could be done is a huge effort which is being initiated by one group in Uttarakhand called the Chirag. And what they are doing is coming up with a plan, not just for Kumaon and Garhwal, but they are coming up with a plan for the entire Himalayan region in terms of a springshed recharge program, really working around community initiatives. So when you have a bureaucracy which builds dams, or when you have a bureaucracy, as Leela pointed out, which is only interested in infrastructure development and not really using how water relates to people, you have certain gaps. And what organizations or social capital can do, and an investment in institutions like Chirag, you could actually come up with a whole village level plan in terms of greater recharge. There is Vivekananda Foundation in Karnataka, which is also doing similar work in terms of groundwater recharge, which is again something which I think the irrigation bureaucracy needs to start looking at. So what really was a conclusion, and that was really greater decentralization. Greater decentralization, not just in letting the central bureaucracy take over the very institutions, but really in terms of opening up the governance structure, which is what Leela is talking about. So we find that water is not just an economic aspect, but it also relates to certain values and certain cultural aspects. And the definition in which people would like to relate to water would depend in different conditions in different ways. My idea of giving you this wide different images is try to show that the governance structure or the alternate governance structure in each of these cases would be very different. So having a single model of governance, which is what the state would like to see being adopted throughout the country, is really going to be a problem. On the other hand, if you let people themselves, give them the ability, craft institutions, you would be able to do much, much more. Climate is not something which is outside the wider economic structures. And here I would come back to what Christian said in terms of convergences. The local government structure helps departments work together. So instead of the irrigation department, the drinking water department, the agricultural department, what the district level institutions would actually like to do is in terms of a convergence. And that is the kind of a convergence which your water institutions require. And I think the local governance institution is something which will help you get access to resources vertically through state institutions, through international organizations, and also would be able to work in a very horizontal manner in terms of integrating many of the issues which revolve around water. Thank you.
Thank you very much, Satyajit. Siddharth, can we turn to you next?
Yes.
There is a presentation.
So until they get the presentation, so I will be summarizing, first of all, some of the most pressing water governance issues facing India, what we discuss internally over the council at Namami Gange program, that is the National Mission for Clean Ganga. And I will be specifically focusing and going into details into two specific aspects. One is about the demand management measures, and the second is about water circularity. So,
my question relates to a topic that none of you touched, and I wondered whether it was because it is too hard or because you don't think it's important. And that is the issue of river interlinking and the amount of water from the Western Ghats that runs to the sea and that nobody is bothered to collect sufficiently.
I'm happy to take a crack at it, and my colleagues here are welcome to actually disagree. So water that flows to the sea is not necessarily wasted water. Just because it's unused, it's not wasted. It provides ecological services. Our deltas, are probably the most fertile. You need only look at the Indus and see what's happened to towns like Thatta and Bada, where poverty levels are probably amongst the deepest that you would find on the continent, to see what happens when you destroy the delta because of salination, right? The seawater begins to intrude. So, what the environmental flow is and what the sustainable levels are, I don't know in particular, but the only thing that I would state is just because water flows to the sea, it is not wasted water. It is necessary that you get those flows to the sea. That's why they're called environmental flows. But others on the panel might have other views.
So I fully agree with what Richard said. So, the biggest consumption of consumer of water in India, the biggest source of consumption is the groundwater. And these flows provide a big recharge opportunities for groundwater recharge. So that's one of the aspects. The second aspect is, as Richard mentioned, the ecological flows, because the biodiversity, to maintain the biodiversity, which kind of feeds into the food chain, for that the ecological flows are very important. Anything else you would like to add? Okay.
Please go ahead.
Okay. So as I said, I'll kind of summarize some of the most pressing water governance challenges facing the country. Most of my panelists have already covered many of these subjects. I'll touch upon quickly some of them and go specifically into the details in the last two. The first aspect I would like to touch upon is how do we incorporate valuing water in our policy landscape. So when I say value water, what I mean by that is looking at or considering water as a tool for social progress and economic development. The valuation of how do you value water is different from the cost and the price of water. For example, the city of Bangalore, it's a big urban conglomerate. but it has to lift water almost 500 meters before the water gets into its distribution system. So the value of water for a city like Bangalore is very different for a city like Pune, which is gravity fed most of the time. So incorporating value of water in the policy landscape, I think, is one of the major governance issues that we need to look at. Second is, I think most of my earlier panelists addressed the point of institutional and administrative structures. In fact, as Professor Singh mentioned, the Mihir Shah Committee report has already recommended merging the Central Water Commission and the Central Groundwater Board to have more seamless decisions on water resources management allocation. Regarding the management and regulation of groundwater use, again, a lot has been spoken about it. One particular feedback loop that is prevalent in the management of groundwater use is what they call as the competitive extraction. So if one farmer has drilled a bore and that farmer is extracting more water, the farmer's neighbor has to drill more deeper and deeper, and that further affects the water tables. In fact, there is a direct linkage between receding water tables and the river flows, or what they call as the subsurface flows. So the more you extract water from the ground, the more the rivers are likely to dry up. So there is a direct connection between the river flows, the ecological flows in the river, and the groundwater. And a holistic approach needs to be taken to ensure that the groundwater table is maintained so that the river water flows are also maintained for the ecological purposes. The river basin management approach is also a very critical aspect, wherein the river is not a single or an isolated entity by itself. When you look at the policies around management of the river, the tributaries, multiple tributaries which feed into the river, have to be looked in as an ecosystem for the policies and management of the river itself. In the 80s and the 90s, the government of India had initiated the Ganga Action Plan and the Yamuna Action Plan for cleaning up of the Ganga and the Yamuna, but the tributaries were ignored. Now, after 2014, when they have the National Mission for Clean Ganga, they're looking at a basin management, and that same approach is now being incorporated into some of the other river basins across India. So that is about the river basin management approach. Dr. Debroy also spoke in the earlier session about data sufficiency and data accuracy across the economic indicators, and water is also not immune to the lack of sufficiency of data and the accuracy of data. The climate change adaptation and water security, Professor Singh also touched upon this topic. We often talk about carbon emissions, or rather when we talk about climate change mitigation adaptation, we focus a lot on the carbon emissions, but we often ignore the implications on the water sector as well. It's often referred to as that climate security is water security and water security is climate security. So it's kind of it's intertwined with each other, and it needs to be looked again in a holistic fashion. The demand management measures is something that I'd like to go into detail again for here. A lot of it is ignored in India because it's a very supply-centric approach towards water management. And I would like to touch upon some of the demand management measures which can be, some of the challenges and the opportunities related to that. And then lastly, the water circularities. We have a limited resource. It's rightly said that water is too precious to be used only once. So how we can incorporate policy measures by which allows us to use water more than once or more than twice, and that's the concept of water circularity. Regarding the demand management measures, the challenges, I've just listed down some very pressing challenges. So as I said, we have a very supply-centric approach for meeting water demand. If there is a shortfall in the supply, we build new tanks. We try to look at building small reservoirs. We try to look at building desalination plants. But the demand-side efficiency measures are often ignored when we talk about matching the supply and the demand. And I think that is a big opportunity also when it comes to how we can supply sufficient water to our urban areas. We also know that there is a huge political economy associated around water tariffs and water pricing and actually collecting those water charges. from urban cities, from the residents. And that's a big challenge which, if it can be solved, that can solve a lot of problems, but that is a challenge by itself. And linked to that is the non-revenue water, which is basically the leakages in the pipeline, and again, the political economy, which confers some of the free connections to the residents in the city. Now, the opportunities with regards to demand management cover incentivization of water use efficiency. So, the Ministry of Jal Shakti has already proposed what is referred to as the National Bureau of Water Use Efficiency, NBWUE. Unfortunately, it's still on paper. It's not translated into a policy action yet. But what it intends to do is similar to what Singapore or Australia has done in terms of introducing efficiency labeling standards to fittings which consume and use water. If there is a faucet which is consuming 15 liters per minute, how it can be gotten down to 5 or 3 liters per minute. These are some of the actions which the work has already been going on, but it's still on paper, as I said, and I'm sure that in the next 1 or 2 years, that the policy should be rolled out. Then, in large parts of the urban conglomerates, the metering systems are still absent. And even in a city like Pune, where I live, with a population of about 5 million people, only 30% of the pipe connections are metered. Most of them are, the water tariffs are not existent, and the collection happens on a property tax basis. So if we can look at investments which allow to set up the water meters, there are, so as Mr. Kunal Kumar mentioned in the morning, through the Smart Cities mission, they are looking at installing meters across India. It's still in a very small base. It's increasing day by day. But once we do that, we'll at least have an understanding how much water we are consuming in the first place. Right now, where exactly that water is going and who is consuming that, we don't have the exact data around it. So again, it feeds back to the data sufficiency and data mapping problems. And the last part with regards to the demand management measures is how we can inculcate and imbibe behavioral changes and sensitize the population. We all know, like many of us, inadvertently while brushing teeth, we keep the faucet flowing. So can we incorporate some behavioral changes in the population through some communication and educational programs by which we can reduce the avoidable wastage of water. The next aspect I would like to cover is water circularity. Again, this is more to do about the notion of water being too precious to be used just once. We need to try to see opportunities how we can use water more than once or twice. The challenges regarding water circularity in India are that there is a lack of comprehensive policy for recycle and reuse of, I'm calling it used water here because that is the term that now should be used instead of wastewater or sewage. In fact, as we speak, the Ministry of Jal Shakti is re-christening the sewage treatment plants as Nirmal Jal Kendras. Nirmal is pure, Jal is water, Kendra is center. So going forward, they will be called as Nirmal Jal Kendras rather than sewage treatment plants. And that's a mindset change which the Ministry of Jal Shakti is hoping to achieve, to look at water treatment plants or wastewater treatment plants as an asset rather than a liability. The second aspect, the second challenge we observe is that the discharge regulation and the technologies used to create, to treat this water are creating some cost barriers to introduce circularity and develop a circular market for water. The National Green Tribunal, through its order in 2017, has mandated very strict discharge norms across India, irrespective of what the end use is, which has some limitations in terms of how we can develop a market for recycle and reuse, which the government is taking over. Just
wrap up.
This is the last slide. Okay. And also we already have building codes that promote recycle and reuse by separating the gray water, black water lines, but the implementation is not as high as it should be. So the challenges around that, what I mentioned, now the opportunities in water circularity is that we need to define the right scale of decentralization of treatment when it comes to water circularity to shorten the loop of water supply, water treatment, and so on and so forth. if there can be some tariff incentives for promoting use of treated water. The Pimpri-Chinchwad Municipal Corporation, which is a sister city of Pune, they are now setting up a plant to treat the secondary treated wastewater for industrial reuse, and they're offering a 30% discount on the purchase of using treated water. And there should be investment in development of technologies for decentralized treatment. In fact, Stanford University, across the building, the Y2E2 building, they are doing some wonderful work in promoting and developing and promoting technologies which can be energy neutral and also produce less sludge, which reduce the operation cost a lot. So that was my presentation. Thank you so much.
Thank you. That was great. What I'd like to suggest is now we take a few questions from the floor. Yes, please. Give the mic to you.
Wait.
Give a mic for you.
To Satyajit Singh, I know of 2 NGOs in India who are working on the water conservation problem. One is called Pani, and the other one, I forget the name, but it started by Desh Deshpande. How effective are NGOs in helping solve these issues or bring to clarity some of the problems that we can take care of there?
That's a good question. The question really, the answer to that would be how are NGOs facilitated by the state or the donor community to be able to bring about effective change. So it's very easy to find small, innovative projects. The question is, how do you scale it up? And then there are problems of scaling it up. The Swajal was a great experiment through which the entire rural water sector reforms came up. But as Leela pointed out, that when you scale it up, the state comes up with strict guidelines in terms of what has to be done. The state also comes up with 2-year time frame. Why will you want to bring about this process of change? And what we see is that the way the NGOs were successful was really a longer term interaction with the community, with the resources, with compromises and negotiations of who is taking how much water. Because if you're talking about conservation, then you're also talking about access of water to different communities. So certain NGOs are also successful in certain social conditions where you have harsh caste realities and a distribution of land. They will not be successful. So that is where I would say a convergence between the NGOs and local institutions becomes important, because that is really citizenship. That is where you could actually say the Constitution gives you, there are certain functions which have been transferred to the panchayats, and drinking water or irrigation happens to be one of those kinds of resources which has been transferred. So you have then an access to the entire infrastructure of the government. And you also have institutions which help build social capital over a long period of time converging. So I would not say get the state out completely. I would say the state is the people, and decentralization is a way through which that convergence takes place. Of course, there is a lack of capacity at the local level, and that is where I would say NGOs would help in building capacity. But if those NGOs are not linked to state institutions, then they would also run dry very soon.
That's great. Thank you. I think we've run out of time now. Let's give all our speakers a big hand and go to the next session.